In this video, we're going to begin our venture into the world of geometry, into the world of area in particular. Yesterday in class, we did talk about the area of rectangles, the area of squares, as well as perimeter, and then we also began talking about triangles as well. And then today in class, we did a little venture into the world of area of parallelograms as well. So some of this will be a review, but hopefully it'll be worthwhile for you. Okay. So just to review with the area of parallelograms and what we did in class, we started off at one corner here, and then we drew a line straight down so that it would meet at a right angle. Okay. Then we took this area here, that triangle that was formed, cut it out, and we moved it over onto this side. So now if I look at the new shape that was formed, what am I dealing with? Well, if I look, it's basically one big rectangle. So if I take these measurements, and let's say I know my height is 4, and my base is 9. Let's say this is 9. Okay. Keeping in mind that let's go and use a different color. The two units here were moved over to here. So it's still the same 9 spots, basically. If I look at the area of my original parallelograms, okay, and this isn't drawn to scale at all. Let's pretend this was 9, pretend this was 4 again. If this was meet at right angle, okay, and usually this we draw as a dotted line, just batting 1,000 here. Okay, this means a right angle. I'm basically saying, okay, the area is still going to be the same as this black rectangle. Therefore, I look at the area of a rectangle, and I know it's going to be given by my length times my width. This is for a rectangle. For a parallelogram, since we don't talk about lengths and width, but instead we talk about our base and our height, we say that the area of a parallelogram is going to be given by the base times the height. And this carries over to triangles as well. Okay, we talked about the area of triangles by first off starting with a rectangle where we said, okay, we know that the area is given by the length times the width that meet at a right angle. So in this case, it'd be given by 4 times 5, which would then give me 20. Well, to get a triangle, all I would have to do is draw a line like this, and then using the same corner, I get a triangle. Well, what's the area? Isn't it half the area of this triangle, half of the total rectangle? So therefore, if I knew what the length times the width is, I would have to divide by 2. So I would get an area of 10 units squared. Okay. So another way of writing this would be area would equal the base times the height divided by 2, or we're also going to see it written as 1/2 base times the height. Okay, both these mean the same thing. Basically, multiply the base and the height, the two measurements that meet at the right angle, okay, and then divide by 2 or multiply 1 by 1/2. Why is this important? Well, sometimes we're given a triangle where there is no clear base and height. There's nothing that's defined as meeting at this right angle here. So sometimes what we have is we have a line drawn in like this, meeting at a right angle, and for example, I might say that this is going to be 4 centimeters, and I know that my base is going to be, say, 9 centimeters. Okay, this is looking a lot like the same measurements as the last page, but that's okay. Okay, in this case, to find this area, the area of this triangle will be given by the base of 9 times the height of 4, and then I'm going to divide by 2. So it's going to be given by 36 divided by 2, which would give me 18 centimeters, and then I square it. Okay. I can write it as 18 centimeters squared, like what I did here, or it's also written as 18 square centimeters. Okay. Most times we abbreviate it because it's a little bit quicker. Okay. Once again, another way of writing this is to say it's 1/2 times the base times the height as well. Okay. So either way of writing it, you can write it as 36, then take half of 36 and get 18 centimeters squared, or I can multiply the 9 times the 4 and then divide by 2 afterwards. Okay, this has been nice so far. Okay, what's the area of a parallelogram? What's the area of a rectangle? What's the area of a triangle? In real life, though, when we actually use this, say as figuring out how much carpet we need to lay in a room, not everything's perfectly square or rectangle or triangle is shaped or parallelogram. A lot of times we might have a figure like this, where it gets a little more complicated. Okay, like say in a scale drawing. This could be a room, for example, that needs to be carpeted. It's not just one shape, so we can't just take one measurement and multiply it. But what we can do is divide it up into the measurements that we do know. So, for example, I could take this and I could form one rectangle here. Okay, such that I know that this side is 7, this side is 4. Okay, what I then would also have to do to make another rectangle, so I have the rectangle that I'm going to line in red and say this is a 7 by 4 rectangle, which means that this area is going to be 28 units squared. Okay. I have another triangle, or another rectangle that's formed by the green outline. Okay. And it's given by the fact that this measurement is 10, this measurement's 9. So this is a 9 by 10 rectangle, which would give me 90 units if I multiplied it together. But I also have to remember that over here I'm left with another small rectangle. And it's clear that I'm given this 6 units. And because it's backed on graph paper, that this is 2 units. But if this wasn't backed on the graph paper, I could still figure this out by saying this whole distance is 4, but I have to take away 2. Okay? So that would leave me with the 2 here. So I could branch it off up to 2. I could also look and say, okay, this is 10, but then in order to get the full length of 12, I'm left with 2 as well. So this would give me a 2 by 6 rectangle, which would give me 12. In order to figure out the area of the entire figure, I would need to take the 12 from the blue, the 90 from the green, the 28 units squared from the red, and then I would need to add them all together. Well, when I do add those together, I would get 130 units squared for my area. Okay? This is not the only way you could break this up. For example, instead, I could break it up like this. And by looking at the shape, I can see that I'm going to break it up completely different. The red is 108, the green is 6, the blue is 16, completely different measurements, and completely different areas. But when I add it all together, I get 130 units once again. So it's about understanding how you're breaking it up, and it may be useful to use different colors for you, so please feel free to use colored pencils, or colored pencils would probably be the best for you to use. So I hope this has been helpful, and we'll continue to practice this.